Hey, hi everyone. Very good evening to you all. Uh, just quickly in the chat section, can you all please tell me if my voice is clear and if my screen is visible? Okay. All right. So, how are you all? Just quickly in the chat section, let me know how you all are doing. Hey, hi Shubham. Hi Nisha. Hi Soumya. Hi Sneha. Very nice to see you all. Okay, nice to see the excitement. And I want you all that whoever are in this session right now, please give a thumbs up to this video. Let's just wait for few more minutes and then we shall be starting. All right. Yes, Jagan, we are doing string questions as well. Just stay updated with us. We are covering questions from all the topics. Yes, thanks Shubham. Thanks Soumya. Hi Meshkat. All right, so we are good to start. Okay, so let us see what are the three questions that we are going to discuss today. All right, so the first question of the day is count leaves in binary tree. My screen is visible, right? Okay, thanks Adarsh for confirming. Thanks Neha. All right, so the first question of the day is count leaves in binary tree. Now let us see what the question statement reads. Given a binary tree of size n, you have to count leaves in it. For example, there are two leaves in following tree. All right, as we can see, 39 and 5. And an example is given to us in that there is an input, all right, in which the given tree is 4, 8, 10, 7, 5, 1, and 3. And the output is 3 because there are three leaves. Okay, so tell me in the chat section, what are the three leaves of this tree? Okay, everyone, please help me with this. What are the leaves of this tree? Yes, 351, right? Right, Sainath, right, Adarsh? Yes, correct. Yes, Soumya, that's a correct answer. All right, so this is how. So I guess the question is clear to you all. I will just draw a tree and I will let you all know more clearly. Okay, so let us say we have a tree here. Let us say this is 1, this is 2, this is 3, 4, 5. All right, so the leaves of this tree are 4, 5, 3. Is it clear why these three are the leaves of this tree? Okay. All right. So now okay, I want you all to help me with how you all decided that these three nodes are the leaf nodes of the binary tree. So I will just explain to you the property of a leaf node. Okay. So the property of a leaf node is the right child of our leaf node is equal to null and left child of our leaf node is equal to null. Is it clear? Yes, we have a correct answer. Shubham, that's a correct answer. Sainath. And okay, Abhishek, we are doing a question that a binary tree is given to us and we need to count that how many leaf nodes are present in the tree. Okay. Yes, Adarsh, correct answer. All right. So we are checking here that the tree which is given to us, in that tree, how many nodes are present such that they have neither a right child and neither a left child. Okay. If there are such nodes, then we need to return the count of those nodes. All right. So the question is clear. Okay. So now help me with the approach. How can we start doing the question? First of all, let us see how can we do it recursively. Okay. First of all, let us see for recursive approach. So, okay, what will be the base condition? Because whenever we are using recursion, the most important thing that we need to keep in mind is there must be always a base condition. Okay. So, yeah, tell me what should be the base condition? Very good, Shubham. That's a correct answer. So, we are writing here if not root, we can write it as, then we will return 0. Okay. Yes, others, that's the right answer. Now, what shall I write here? What is our condition for a node for being a leaf node? If not node right and not node left. All right. Then we shall be returning 1, right? Is it clear? And then at the last we will return, let us say our function name was solve. We will solve for our left and plus we will solve for our right. Okay, so is this snippet of code clear to you all? Yes, Adarsh, that's the correct answer. Okay, so tell me, is this note clear to you all? Okay. All right. So what I said here is, let us say we have a tree. Okay. All right, we have a tree here. So what are we doing is, first of all, we are checking this is the base condition. As we know, every recursive function must have a base condition. Okay, so first of all, we are checking that if no root is there, okay, like if we reaches at the end of the tree, or if suppose an empty tree is given to us, okay, in that case we are checking that if there is no root, then we will simply return 0. Okay. All right, then we are checking that this is the condition to check for a leaf node. Okay, tree leaf. We are checking that, see, 4 is a leaf node, right? Why it is a leaf node? Because it is not having a left child and it is not having a right child. So we are checking here that if there is no right child present and no left child present, then we will simply return 1, because that counts as a leaf tree. All right, that's why we are returning 1. And then we are calling our function recursively for the left child of the root and for the right child of the root. Okay. So this is a recursive code. Is it clear? Shall we okay, I'll just explain one more approach. Okay, so I want you all guys to figure out what can be the second approach to this. One is recursion, and there is another approach as well, using a data structure. Okay, I can give you a hint. We are going to use a data structure. Exactly, correct, Adarsh? We are going to use Q. Yes, iterative function, right, Sainath? Yeah, so what are we going to do is, like, let us suppose this is our Q and say this is our tree. 1, 2, 3, 4, and 5. Okay. All right. Yeah, correct. BFS approach. Correct. So, okay. What are we going to do is say this is our queue. Okay. So, in this queue, we will, sorry, this is our tree, right? So, we will be inserting one by one nodes from the tree in our queue. Okay. So let us say, first of all, we will insert one. And after inserting one, we will check that if one is not having a right child, as well as if one is not having a left child, then let us say we have a counter. We will increment the counter, okay, because that is our leaf tree. And then we will write a condition that if there is a left child of a node, then we will push it in our queue. And if there is a right child of a node, then again we will be pushing it in our queue, and we will repeat this operation till our queue is not empty. While not queue dot empty, we will repeat this operation. Is this approach clear? Is this approach clear to you all? Using heap, no, heap cannot be of any use in this question, I guess, because we just need to count leaves, and heap are mostly used, when there is some max element or min element that we need to take in count. So yeah, let's code. Yes, that's nice. Okay, so what I'm saying here is, yeah, sure, I'll just repeat. What I'm saying here is, let us say a tree is given to us. So what we will do, one by one, we will keep on inserting our nodes. All right, let us say, first of all, we will insert our root. Okay, one is there. Then we will check if one is having a left child or a right child or not. Okay, if none of the child is present, then we will increment the counter, and if the child is present, then we will just pop it out, and we will insert the left and right child. Okay, so our new queue will contain 2 and 3. Same process we will repeat for 2 and 3. Okay, so now tell me, is 2 is having a left child and a right child? Is 2 is having a left child and a right child? Yes. So we will insert it in our queue, and we will pop it. Okay. So, and it will not count towards our leaf node. Now tell me, is 3 having left child and a right child? Yes, Adarsh. Meshkat, Sainath. Correct answer. Jyoti, yes, that's a correct answer. No. So means this is not having a left child and a right child. So shall we increment our CTR in this case? If not having a left child and a right child? Yes, so our CTR will be incremented and we will pop out 3. Okay. Now our new queue is looking like this. Okay, so same process. Yes. Yeah. When if in answer we need to return a vector, then we can add it in a vector. But here we need to return the count. So that's why we will do CTR plus plus. All right. Now see the new queue that we are having. It is 4 and 5. Both of these are leaf nodes. Correct. Okay, so both of these are leaf nodes. So that's why what will happen, our CTR will be incremented once again. And then at the end of our loop, we will simply return CTR. Okay. So is the explanation part clear? Are we good to start with the code? Yes. Okay, nice. So yes, great in CTR. So first of all, let us declare a Q node star Q. All right. Now, first of all, q dot push, let us push our root inside it, and we will be running our loop till the queue is not empty. Okay. Now, int n is equal to q dot size by n minus x. Okay. Node star temp is equal to q dot front, and simply we will do a pop. Okay, now what shall I be writing here? You all have already figured it out. I just need it once again so that I can write here what we need exactly. If what is the condition to define leaves? Exactly. If not, temp left and not temp right. Exactly. Then what we will be doing? We will be doing CTR plus plus. Okay. Is this clear? And now for pushing, yeah, exactly, that's correct. Kamal, Sainath, Shubham, that's correct answer. Adarsh, yes, correct answer. And now what we are going to do is we are just pushing left and right child, okay? So if temp left, if left child is there, then we will just push in our q dot push temp left, and if temp right, q dot push temp right. Okay. So next we have done CTR plus plus, and here we will return CTR. All right, let's see. Hey, hi Shubham. Okay, guys, so we have solved this problem. Congratulations to all of you. So, is the code clear to you, and is the logic clear? Just give a thumbs up in the chat section. Hi, Yogesh. Yes, clear. Okay. All right. So, let's move to our next question. Okay, that is, we have to print left view of a binary tree. Okay, so the question statement reads as, given a binary tree, print left view of it. Okay, left view of a binary tree is set of nodes visible when tree is visited from left side. The task is to complete the function left view, which accepts root of the tree as argument. All right, a question, an example tree is given to us, and then we just need to print the left view of our tree. Okay, let me explain the example. Um, say this is our tree 10, 20, 30, 60. Okay, so tell me guys what we will write as the left view of this tree. Yes, node star is a data type. Okay, it is a user defined data type, because these data structures, which is a user defined data type, which is defining tree as a data structure. Okay, in that we have pointers, we have a left pointer and we have a right pointer. Yes, that's a correct answer. Shubham, Sainath, Adarsh, Jyoti, Priyanshu, Shagun. Thanks for giving the correct answer. The left view of this tree will be 10, 20, 40. Okay, so okay, we are clear on this part, that what we are exactly doing. We are just viewing the tree from the left side, and whatever we are getting, we are printing it. Okay, so now tell me, what is the first approach that is coming in your mind? Yes, Soumya, that's the correct answer. How are we going to check this, the left view of a binary tree? Pre-order. Okay. Okay, so okay, so in the previous question, we have just seen that how are we inserting values inside our queue. Okay, so let me tell you one thing. Let us say, first of all, we are inserting 10 inside our queue. Okay, so what is here we are queue dot size. Okay, all right. So what is our queue dot size in this case? It is 1. Okay, yes, level order traversal, very good. Q dot size is 1. All right. So, and is 10 is in our vector? Is 10 is on 10 is in our answer vector? Yes. Okay. So we will insert 10. All right. Now let us say we are popping it, and then in the new queue we are adding left child and right child. Okay. Now q dot size is 2. Is 20 is in our, this was 0. Okay. This is 0. This is 1. Is 20 in our answer vector? Yes, Priyanshu, you are correct about the logic. Yes, 20 is in our answer vector, so we are adding 20. And when we will pop out 20, we will always insert its child. Okay. Is 30 in our answer vector? No. All right. So we will pop it out and we will insert the child of 30 as well. Let us say, let us take a child here of 30, say as 70. Okay. Always remember, whenever you pop out an element, insert its left and right. Okay, left and right child. So we are popping out 30 and we are inserting its left child as 70. Okay, now we have 0, 1, 2 and q size is 3. Is 14 our answer? 30 not, because when you will view your tree from left side, you will be only seeing 10, 20 and 40. You won't be able to see 30, right? So that's why, Rohit, we have not added 30 in our answer. Okay, so 40 is in our answer vector. So we have added 40. Are 60, 70 in our answer? Okay. Yeah. No. 60, 70 are not part of the answer. Okay. So you all tell me what is the one pattern that you are observing here. Okay. When the queue size, I will, okay, just a second. When the size, and here I am writing element added. When the queue size was 1, when the queue size was 1, the element that was added was at the index 0. All right. When our queue size was 2, the element that was added is, just a second, again at element 0. And when our queue size is 3, the element added is again at index 0. Okay. So any pattern that you all are observing. Yes, Abhishek, I will just answer that question of yours. That is, we are doing for these cases. See, in this case, what is the expected left view? We don't want left child of our nodes. We want left view of the tree. Okay. So if this was the case, if our tree is like this, and if you will not insert its left, see, the answer of this tree will be say 1, 2, and 4. Okay. Yes, Shagun, Vibha, that's the right answer. Okay. So see, if you will not add the right child here, okay, so in that case, this 4 will get missed out because you have not added right child. Okay. So that's why we are adding it. Okay. Is it clear why we are adding left child as well as right child? This is the left view of tree. Okay. So yeah, so as I have said that whatever is the size of the queue, the element that is getting added is always present at index 0. Okay, so any idea from this that what are we going to write in our code while empty the queue? I mean, when we are adding the elements and when we are popping out the elements, what is the one condition that we are going to check to see if it is left child or not? If, okay, so tell me what is the one condition that we are going to check? Very good, Adarsh. If index 0. All right. So what if I is equal to 0, then it means it is a part of our what? Left view. Okay. Okay, Devesh, the question is to print left view of a binary tree. All right. So are we good to move to the coding part if the question is clear to you all and the explanation part is clear? Okay. Yeah, clear? Okay, great. So let us move to our coding part, and here we are starting with left view of a binary tree. So we need to return the answer in a vector form. So we have first of all declared a vector, then we will create a queue of type node star. Q, and we will be pushing root inside it. Okay. Now, first of all, we will write while not Q dot empty. Okay. So what we need to do is int n is Q dot size, and now for int I is equal to 0, I is less than n, I plus plus. Okay, what is the condition that I shall write here? Help me with this. You all have already figured it out. I just need it in a code format. What shall I write here? Okay. See, the logic was yes, Adarsh, that's the correct answer. Very good. So, see, logic that we are using is yes, Meshka, that's the correct answer. Okay, so logic that we are using it is one by one we are inserting elements in our queue. Okay, say like first of all we will insert one. Okay, then we will pop out one. We will insert its child. Okay, say 2, 3. Then we will again pop out 3. Then pop out 2, and then we will pop 3, and then we will insert their child. Okay, so we are continuously inserting child inside our queue. Okay, but one case that we have noticed is for our answer array, the element that are present at index 0. Index 0 means the front element of the queue. Okay, whatever is the current front element of the queue, that is consisting the part of our answer array. All right, so that's why we are checking that which element is present in the front of our queue, and that we are adding in our answer vector. Okay, so that is the logic, and that's we are coding here. Okay, so there are multiple correct answers. Yes, Soumya, that's the correct answer. So if I is equal to 0, then we will write here res dot pushback. All right, we have to create a node start temp as well in this case. Node start temp is q dot front q dot pop. Okay, I is equal to 0. Okay. Yes, exactly. After popping 1 and 2, 3 will get in the front. Okay. Not res, sorry, it's q dot push, and right, then we will push and right. Okay, all right, so have we added answer? Yes, we have added answer, and then we have this, we will be returning this. I'll just answering all the queries, just a second. There is this runtime error. uh, just give me a second. Vector interest q star q and n is q dot size. I0 does not push back temp data. If I is 0, then we will simply push temp data, and if temp left, temp right. Why runtime error? Okay, guys, just give me a moment. Okay, we need to add a base condition here as well. Okay, so always remember to add base condition in trees. If not root, return an empty. All right, so yeah, here just we saw that base conditions are very important in these three questions. Okay, always keep that in mind. So yeah, we have added a base condition here, and then this is the code that we have written for our answer. So what are we doing is, first of all, we are adding elements in the queue. Yeah, that base condition. Okay, now see, what are we doing here is, first of all, we are running our loop, all right, and we are inserting elements inside our queue. Now while we are inserting elements, first of all, we check that if the current element is at index 0 or not. Okay, and if that element is at index 0, then we simply add it in our vector. All right, and then after adding, we insert the left child and we insert the right child. So this is the code for this question. Let me know if anyone is having confusion in this code. Is everyone clear with this code? Okay. Yes, thanks, Shubham. Thanks, Adarsh. Thanks, Devesh. Okay, so we have already done two questions from the trees. So, okay, I just want you all to answer me. Just answer me one question. What is the difference between the real tree that we see in our nature and this tree that we are discussing? Okay, there is no any correct answer to this. You all can answer whatever you feel like, but there must be some logic. Okay, also answer one thing. I mean, what is coming in my mind right now? Okay, Mohan, reverse. Yes. Any other answers? Real tree grows from bottom to top, and this is top to bottom. Yeah, that's correct. Root. Yeah. So like that's the only answer. And again, this is a binary tree. All right. So, yeah, exactly. Kamal. Real tree has many leaves. Okay. My question was, what is the difference between the real tree and the tree that we are solving in this question? Real tree has more roots. Okay. I mean, tree has only one roots, right? Maybe we can have many roots. We have just a type of root like lateral root and fibrous roots. I'm not sure about if we have many roots. Yes, real tree may have more than two child. Yes, that's a correct answer. Yes, Jyoti, bottom to top and top to bottom. Yes, Soumya, real tree can't be empty. Okay. All right. Okay, so yeah, thanks for answering. The answers were really very innovative. Are we good to go to our next question? All right, before that, I want you all just please do me a favor and give a thumbs up in this video. The like count should increase and it should be as much as the viewers that we have currently. So please just go and hit a like button. Yes, Abhishek, that's the correct answer. Yes, Adarsh. Yes, Priyabrata, that's a very nice answer. Real tree gives us oxygen. I mean, I was thinking, yeah, the same thing that, in real tree, it is always from roots. Roots are at the bottom, and here roots are at the top. So my answer was like that. Thanks, Adarsh, for liking, sharing, and subscribing. Everyone, please do that. I shall be very thankful to you all. And also, you might aware about this thing, the sheet that we are solving. It is this SD sheet, right? So just keep on solving questions from this sheet. The questions are from all the ranges, from all the topics. All right. So just keep on solving these questions and develop your logical thinking. The more you will practice the questions, as I say, the more you will become perfect in this. So this is the sheet that we are following. So don't forget to, access this sheet and solve the questions. All right. Yes, Adarsh, correct answer. Thanks, Shishir. Okay, so are we good to start with our last question? Just share me in the comment section if we can start with our last section. Good evening, Shishir. Okay, so I can see only one yes. Can I get multiple answers? All right, guys, the one very important thing that we have missed in these two questions were we didn't discuss one thing, and none of you reminded me for that. What was that? We forgot one thing to discuss in both of these code. A sheet link, you can get it in the description. Exactly, Adarsh. We didn't discuss about the time complexity and space complexity. So let us discuss that. Yes, Meshkat. Okay. So the first question was count leaves in binary tree. Yeah. So what is the time complexity of this? You guys only tell me that. What is the time complexity? Yes, Sachin. Yes, Priyabrata. That's right. Very good. The time complexity is linear because we are visiting all the nodes. All right. And what is the space complexity? Yes, Adarsh. Yes, Devesh. That's right answer. Linear space. Okay. Sainath, Rohit, Shubham. Hi, Hindush. No, Devesh, this is not a constant space question because we have used Q here. Okay, so we are using a linear data structure. All right. Yes, Sachin. Yes, Shubham. Yes, Soumya. All right. So that's the correct answer. So we are done with this. Now, in this left view of binary tree, what is our time complexity and space complexity? Same. Okay. Correct. Correct answer. Okay. I'll be sharing the link in the chat section itself. Yes. Same. Correct. All right, so we are clear on this part. In this question as well, the time complexity and space complexity will be linear. All right, thanks Sachin, Adarsh, Rohit for giving the correct answer. Yes, Jyoti, that's the correct answer. Okay, so now we are good to start with our last question. Now the question reads as, given a binary tree, connect the nodes that are at same level. You will be given an addition next pointer for the same. Sorry, you will be given an addition next right pointer for the same. Now, initially, all the next right pointers point to garbage values. Your function should set these pointers to point next right for each node. All right, this is our question. I will explain with an example. Yes, Soumya, that's the correct answer. Okay, 10, 3, 5, 1, 2. Okay, all right, guys, just a question for you all. What is the difference between a Q and a DQ? As we see, Q is hero of our session. In all the questions, we have used Q. Yes, Devesh, your logic is correct. You are getting the intuition. See, before doing any question, this is the main thing. You know, you should be able to build a intuition. You will be able to develop a logic once you are able to get the right intuition. So, as I can see, you people are very much able to develop it. So great. Yes, Priyanshu, your statement is correct, but I guess it needs some modification. You can use your terms are kind of you can use more correct terms for it. Shubham, I guess you missed the condition for Q. Q only add element from. I guess you just missed something there. Come on, guys. You know the difference between Q and DQ. It's very easy. Good, Adarsh. That's the right answer. Very good. Yes, Shubham. Now you have added it. Yes, Priyabrata. That's the right answer. DQ is no end. Okay. I want a difference. Okay, so the difference is that yes, Soumya, that's the right answer. In Q, what we do, we follow the principle of FIFO, right? First in, first out. We can add in the front, and popping is done from the end only. Oh, sorry, popping is also done from the end only, all right? And whenever you add elements, okay, it gets added at the back. All right, it keeps on getting added like 10, 20, 30. It will keep on getting added like that. And when you will pop, 10 will be popped first, then 20, then 30, then 40. All right. Yes, Abhishek. All right. And what is in DQ? In DQ, what we do, you can perform insertion, deletion from front as well as from back. Okay. So that is the difference between Q and DQ. So keep that in mind. You know, it will be helpful. Now see, this is our tree. Okay. So let me just give a second. Okay. Well, you are having something else. Okay. So see, this is our tree. Yes, Sainath. Okay, so this is our tree. What we are going to do is a next right pointer is given to us. All right. Here it will point to null. Here it will get connected to 5. And for this 5, it will point to null. Here it will get connected to 1. Here it will get connected to 2. And for 2, it will point to null. Is the question and answer to it clear? Like, what are we going to do? Are we clear for the question part? What is the question asking from us? Next, right pointer, which is basically you can tell we are connecting nodes at same level. We will be returning this route only because once we have populated our right pointers, okay, so all these pointers are pointing to the position, so we can just return our root nodes, and that is the correct answer to it. as you can see. Okay, we don't need to return anything as well. We just need to make the connections. Okay, or either you can return the root tree as well. That is also the thing. For this question, you just need to make the connections. Okay, you just need to connect the nodes at the same level. All right. Is it clear what we have done in this question? Okay. Please, everyone, reply in the chat section. Is it clear what we are doing in this question? Actually, in this question, Yuvraj, we are not going to use this logic. Okay, so what are we doing in this question is a tree is given to us. All right, and as we know, in tree we have a left child and we have a right child. Okay, but in this tree it is a kind of different because we have a next right pointer as well. Okay, in tree we have a left pointer and we have a right pointer. All right, now here what is there, we have a next right pointer as well. Now where this next right pointer is pointing, as it is a pointer, it must point to somewhere. Okay, now where this is pointing to, see, this is pointing to a garbage value initially, and the question is asking us to make it point to its next neighbor. Okay, yes, Adarsh, you are having a correct intuition for it. So the question is asking us to make it point to its next right neighbor. Okay. See, what is the next right neighbor for 10? Is it having any next right neighbor? Is it having no? Okay. So it is pointing to null. Okay. Yes, Sainath, Mishka, thanks. Now, what is the next right for 3? What is the next right? 5. Okay. So it is pointing to 5. And now what is next right for 5? Yes, that's correct answer. Thanks, everyone. What is the next right for 5? Null. Okay, as 5 is not having any right neighbor, so it will point to null. Clear? Now, what is next right for 4? It is 1, right? The next right for 1 is 2, right? Now, as 2 is not having any next right, so it will point to null. Clear? So, this is how we are connecting our pointers now. Let us get into some observation. Q dot size and okay. Initially, say our queue is having, what is the 10? Initially, our queue is having 10. Okay, and null. Initially, our queue is having 10. Queue size is 1. Will this 10 point to null? Yes, Devesh, that's right conclusion. Each level ka last node is pointing to the null. Very good. Is this 10 pointing to null? Yes, good. Next is, when we will pop out 10, we will be inserting 3 and 5. Okay, the index value of 10 was 0. Yes, what about q dot size? Here the q size is 2. Now which element will point to null here? 5, right? And its index value is 1. Okay, now we have 4, 1, 2. 4, 1, 2. Q dot size is 3. Null will be point to 2 and it is present at index 2. Okay, so now I want you all to tell me what is the observation that you can make from here. When Q size is 1, then in that case, the element present at index 0 is pointing to null. When Q size is 2, element present at index 1 is pointing to null. Alright. When Q size is 3, element present at index 2 is pointing to null. So what is the observation that we can get? Good, Meshkan. That's the right answer. Let us see if other people can figure it out. Why n minus 2? It is n minus 1. Yes, Priyanshu, that's the right answer. Yes, n minus 1 is correct. Like whatever node is present at index value n minus 1, yes, Adarsh, whatever index is present at index n minus 1, that is pointing to null. Okay, are we clear on this part? Nodes present at n minus 1 points to null. Are we clear for this? Yes. Great. Now tell me one thing. Initially, okay, let me take a new page. N is the size of the queue, Rajat. Okay, initially our queue is 10, then it is 3, 5, and then it is 4, 1, 2. Okay. Now tell me 10 is pointing to null. We are clear for this. Now, okay, where is 3 pointing to? Where will 3 point? Where will 3 point? Let us say this is okay, this is our q1, but when we have popped 10, our q2 will look like this, our q will look like this. Okay, we will pop 3 and we are doing operations on 3, so 3's next pointer, yes, point to 5. Very good. Now what is 5? After popping out 3 from the queue, what is 5? Just try to figure it out, that once we have popped out 3, what is 5 in the queue? See, these are the three functions that we have for q. Q dot front, q dot pop, q dot peek. First q dot push. Let's say when we will do our question for this 412. Okay, once we have popped out 4, it will point to 1, right? So what is 1 after popping out 4? After popping out 4, what is 1? Great, Devesh. That's the right answer. Front element. Yes, Priyanshu, that's right answer. Front, Meshkat, Rajat. Yes, that's the right answer. Devesh. Okay, so now you guys have figured it out. Okay, so 3 will point to 5, which is q dot front. Okay, very good. Yes, Soumya, that's the right answer. Okay, now see what is happening. Once we have popped out 4, 4 will point to its q dot front. Not 4, the next right pointer of the 4. Okay, one's next right pointer will point to q dot front. Okay, now where will the 2's next right pointer will point to? Where will the, yes, yes, everyone, that's the right answer. Q's next right pointer will point to null. So are we clear about the logic? Saina, Devesh, Surya, Priyanshu, Rohit, Adarsh, Ronak, all of you have given the correct answer. So like, are we clear on the logic? What are we doing? All right, whenever we are inserting in queues, we have two things. If the element is not the not the last element, then it is pointing to q dot front, and if it is the last element, then it is pointing to null. Okay, now quickly give me a thumbs up in the chat section if we can move to the coding part. I'm very happy to see the excitement that you people are showing. Don't forget to hit a like button. Okay, so let's move to the coding part. All right, and I guess I need to do a very little work right now. You have already figured it out. All right, so what are we going to do is we don't need to return anything. Yes, let's code. So first of all, we have a queue, node star queue, and we will push root here. All right, now while not queue dot empty, int n is equal to queue dot size, while we just need to check if it is a last. Let us use a for loop here. For int I is equal to 0, I is less than n, I plus plus. Okay. Okay. If, what shall I write here? If I is equal to first of all, let us write for the null. When it will point to null, what shall I write here? If I is equal to what? If I is equal to what? Great, Shubham. Thank you for helping me. Thanks, Priyanshu. Okay, see, we can't use q dot size here, okay, because a q size is a variable. So as because here I have declared int n, so we will be using n here, okay, Priyanshu, right? We don't be using q dot size. Yes, Rajat, that's the right answer, n minus 1. Thanks, Bharat. Thanks, Adarsh. So if I is equal to n minus 1, okay, so we need to have this node start temp is equal to q dot front q dot pop, okay. If I is equal to n minus 1, then m, what we have here next, right, is equal to null, yeah, else m next, right. Okay, what shall I write here now? What will be inside this else? Where will this point? Come on, we just figured it out. Thanks, Devesh. Q dot front. Okay, so we are good to go. Okay, but after it writing this code, there is one thing that I'm missing. So tell me what I'm missing. Thanks, Priyanshu, Sainath, Adarsh. That's the correct answer. Now tell me what I'm missing here. Yes, thanks, Priyanshu. Thanks, Devesh, Sainath. I'm missing the base condition here. So if not root, this mistake we have done in the previous question as well. So we will just return. Now let's see if we have coded it correctly. No, we have not. We have missed one condition. We have not inserted the elements, right? If yes, Soumya, that's the right answer. temp left, q dot push temp left, temp right, q dot push temp right. Okay. All right. So let us submit. Great, guys. So we have successfully solved our question. Okay, line 157. See, as I have explained this, what we are doing is, see, we have this queue. All right, we had 10. Then in the next level, we have 3 and 5. Then in the next level, we have 4, 1, 2. Okay, let me add this. See, at first, we have 10. At next level, we have, say, 3, 5. At next level, we have 4, 1, 2. So in line 157, okay, what are we doing is, if the I value, okay, here I value is 0, this is 0, 1, this is 0, 1, 2, and Q size is 1, 2, 3. So if I value is equal to n minus 1, where n is the size of our root, okay, sorry, size of our queue. So if I value is equal to n minus 1, okay, then we are pointing the next right pointer to null, all right. And if it is not equal to n minus 1, in this case, in this case, and in this case, then we are pointing it to the front element of our queue, okay. Like after popping out 3, 5 will be the front element. After popping out 4, 1 will be the front element. Then after popping out 1, 2 will be the front element. All right. So these are the two conditions. Okay. If I is n minus 1, then next right pointer will point to null. Else, in else condition, the next right pointer will point to the front element of the queue. Okay. So these are the two conditions that we are using. Is it clear? Is it clear, Sainath? Is your doubt resolved? Okay, clear to you all. That's very nice to hear. Okay, sorry, Bharat asked this question. Yeah, okay, Bharat, that is clear to you. Okay, nice to hear. Okay, Q dot front will give you the first element in the queue. Okay, it does not peek it. It does not pop it. It just gives you the value. It peeks into it. Okay, it does not pop it. Okay, Sainath, it does not pop it. Yes, very good. TC is linear. I'm very happy to see you already figured it out. SD sheet link I will just share in the chat box. Wait. Okay, so the time complexity, space complexity, both are linear. Are we clear? Okay, so this was a medium level question, and this was our first day that we are doing trees. So we discussed a basic level question, a easy level question, and a medium level question. All right. So gradually we will keep on increasing our level of difficulty, and I'm very happy to see the excitement that you have for solving the questions. Yes, Soumya, that's the right answer. Okay, guys, so these were the three questions of the day. Next session will take place tomorrow. Every day we have a live session at 10. All right, we every day come live and we help you guys, to solve these questions. Yes, Adarsh, thanks for this answer. That's a correct answer. See, we are helping you to solve questions. The main reason is we want you to develop intuition for it. All right. If you are able to develop the intuitions, you will be able to figure out, what data structures to use, what logic to use. You will be able to figure out once you are able to find the intuition. And as I can see, you guys are very awesome. You guys are like really awesome in figuring out the intuitions. So yeah, please let me know in the chat section how was the session. Yes, homework questions will be given in the Discord channel. Thanks, Adarsh. Okay, guys. Thanks, Shagun. All right, guys. So thank you so much for joining. And actually, rather, I should say thank you so much for joining with this much of excitement and enthusiasm. I will see you all tomorrow. Okay. Thanks, Rajat. Just don't forget to join tomorrow as well. Thanks, Meshka. Thanks, Soumya. Good night and see you all guys tomorrow. Okay. Bye. Good night.